becomes 3.3, right? 3.77. So you take 10 divided by this, that will give you the current. Now for inductor we know that the voltage is out of phase by 90 degrees. Okay, so what you need to do is you take, in terms of complexity, you take 10, 90 degree divided by your current, that will give you this. It's very abstract. Let's move on and we'll come back again. Alright? Now what is this here, class? This is just complex. Second. Now class, here you have a complex number divided by another complex number. When you have a complex number, class, complex numbers, let's say C is equal to N theta and P is equal to N theta 2. Okay, C times D by computations, it will be equal to N times N. And then angle theta 1 plus theta 2. That is for multiplication. For C divided by D, what happens? It will be equal to N divided by N. And the angle, theta 1 minus theta 2. Now this one, please look up. Okay. Now, there are just too many things. One slide, if I everything just have to do that. There's no way I can complete 15 slides in 1 hour. Okay. Alright, so for the case of inductor, you know that your voltage is 90 degrees and your current is this value. So when you plug it in, you get this is your impedance is 3.77 whatever here. Okay? So far so good? Right. No good also. Right. This one I mentioned already. When we talk about AC signals, class, when we talk about AC signals, it must be here in terms of complex number of its signal. Okay? When we are talking about phasor, it is in complex number. And when you talk about complex number, there are two things you need to know. Either you do multiplication or you do addition. Alright? Complex number addition or complex number additions or subtractions or multiplication or division. Okay, so this one, please go back and look at that. Okay. Certain things if you really cannot take in time, take photo. Right? So, for the time thing, class, you have, let's say I have a circuit here. Okay, the whole thing is this class, Ohm's law. Applied. Even in complex domain. Second, and note this class, the impedance of this inductor, impedance of L is equal to J 2 pi FL. Okay? Impedance of R is R, real number. Second, okay, so let's say for example, class, I have a circuit like this. You are to work out your current. How do you go about doing it? You go about doing it is, let's say resistance is 5 ohm. This one here is 3.7, and this one here will be J, right? So what is your check total? Your check total will be 5 plus this. Theoretically, this will be J. Alright? So when you have this, it becomes 5 0 phase, 3.77 90 phase. Okay? That give you J. Then after that, you work out what's your check total. Alright, which is equal to this value in phasor. Okay? After that, whatever your input, which is 10 volts, 0 phase, divide by this. Okay, what is this? This is Ohm's law. And then give you your current in phase. Is that clear? So basically, this is just Ohm's law in complex domain. Alright? Now, if I know this is my current, then what? What is my E? Well, your total, if I know my total current I already, your total E total is just equal to I times that. Okay? But how about ER? Your voltage across your resistor, you just take your I here multiplied by your tech R, which is in this case 5. Right? 5. So when you do multiplication plus, you take your magnitude 5 times 1.8, give you this. And the angle add them together, they give you this. Second, and how about EL? It's the same thing. You have IL times tech L, but tech L is remember 90 degrees. So you have 90 degrees, magnitude 90 degrees. When you multiply them together, take this times this, they give you 6. Angle add them together, give you this. Is that clear? Alright, so all these are complex multiplications. Suppose I have a circuit such that I have E here. I want to find out what's my I. What do I do? Well, what you can do is you take your E divided by your R, get your IR. Take your E divided by your IL, and give you your E divided by JL, they give you IL. What do I do? After that, after you have this and this, you can work out this. Second. Now, alternatively, you can actually work out your check total using this formula. You can work out this. So once you have the check total, which is a complex number, get this, use calculator. Then your I total will just do this, and then give you this. Okay. Now this one you really have to do a bit of it up yourself. here. Now this one is similar to right. One second, similar to that. Actually, I'm quite concerned. I cannot go faster because I think you all will not. But I don't have so much time. So how? You all can feedback, it's not my fault. Okay. Now, capacitor plus capacitor, the governing equation is this. Your I is equal to C dE dt. Now this one is E is the voltage, voltage. Okay, and as a result, you are seeing this. What you can do is by phase, tech C is equal to 1 upon 2 pi Fc multiplied by J. Okay. It should be minus J. Okay. Minus J 1 upon 2 pi Fc. Okay. And so your deck C, it is actually 1 upon 2 pi Fc minus 90 degrees. Okay, minus 90 degrees. So in this case, your current is a differentiate of E, right? So current go first, voltage later. Okay. Now all these things are what is important you may want to know is, and the other one is E is equal to L di dt. Now, as to who leads who, some class, remember this. There's this term here, C verb. Okay. Now, silver capacitor is I lead B. Second, I leads B. Inductor is B leads I. Second, now the rest of this are how do you get this? For example, let's say this is my V here, my voltage here. If I have to differentiate, the slope will be big here, right? Agree? This is, let's say, sine wave. When I differentiate sine wave, what do I get? Cosine, right? So you get cosine wave. So that becomes your current. So that's how you plot it. And then, how do you get your power? To get your power, you can imagine this one is big times small, you give me small. Big times 0, give me 0, right? Agree? And at this point, some value times 0 also will give me 0. Somewhere in between will be something like that. That's all. Right? I don't think you need to sketch all these things. Doesn't make sense to me. Right? But what is important is you need to know this. Right? Now, class, as I say, your Xc here is equal to 1 upon 2 pi Fc. So plug in the different frequency for the capacitor, you get all these different values. And note this, class, inductor is always positive, capacitor minus. Okay? which is what I wrote here, plus I wrote here, right? There is a minus. Now, let's look at the two ZL is equal to 2 pi FL, right? ZC is equal to 1 upon 2 pi FC. Agreed? Now, plus, when your frequency increase, what will happen? ZL increase because F becomes big one. Right? But when F becomes big, what happens to your ZC? You are dividing by a big number. Right? Okay. So what you need to do is given the equation, think about it. And once you know that, this is I think last year they asked a question on how you measure your LC. Sorry, given the component, you don't know whether it's inductor or capacitor. How do you do it? Okay? So essentially, it works on this way. If I supply an AC signal to this one, you will get attenuated. So supposedly I have a circuit plus. If I have a circuit, supposedly I have a circuit R, and then unknown. Okay. If I were to have your VAC known, okay, so different frequency, you have this B unknown. Okay. So by potential divider, okay, you can measure this, right? You can measure this. Once you know this, by potential divider, you know that Z unknown over Z unknown plus R multiplied by your VAC will give you V unknown, right? Agreed? Right? So from here you can work out what is your Z unknown. Alright. Now, if I were to change my frequency, you see how your Z unknown change. If your Z unknown becomes bigger, it is a inductor. Second, if I were to change, if F increase, Z unknown increase, inductor. Otherwise, capacitor. Good idea? Alright. So that was last year's question. About to finish already. So basically, yeah, you just need to apply, and then from there you work out what is frequency, and then work out your ZL. Your inductor will be just whatever impedance you have divided by 2 pi f. Capacitor, do this. Second, right? And finally, if I have a circuit of this, what happens? You can work out your total impedance. Your Z total is equal to ZR plus ZL plus ZC. Remember, all these are complex representation. You need to add them all together. Real part to real part, eventually add imaginary. That becomes a total complex number. Okay? If you want to work out your current, it's easier for you to do a conversion to phasor. Second, and then take your voltage voltage with a zero reference divided by your impedance. That will give you a current. Alright? Now, after that, you have to get PLVC. You just apply here, it is basically complex Ohm's law. Second, that's all. Okay, so for this one here, this is important, and note this. When you have real and imaginary together, do the complex addition. Second, once you do your complex addition, you get your check total, convert it to phase. Alright? After that, apply Ohm's law. What is this? This one is Ohm's law. Complex ones. Second, after you do the Ohm's law, this one is Ohm's law. It is equal to V over Z total. Second. So once you get your current, how do you get the rest? Apply Ohm's law. That's it. Okay, that's why I say, for this one here, Ohm's law is one of the most important, even though simple law. Second. Yeah. I still make it within 1 hour. I will see when